Hi guys, and welcome to another video. Today we're going to be looking at statistics drawing a cumulative frequency curve, Ojive curve. In a previous video, I looked at the interpretation of the frequency curve. The question that I'm going to be looking at today is from the February-March 2011 paper 2. It reads as follows. It says, the individual masses are in kilograms of 25 rugby players are given below. So as you can see, all of the masses are given to us and they are not arranged in any order. It says complete the following table on diagram sheet 1. So therefore, the mass in kilograms be between 60 and 70. So we have to count all of those values between 60 and 70. Don't forget that this is greater than equal to 60 and less than 70. Therefore, all values that you're going to consider are from 60 to 69. And here, all values are going to be from 70 to 79 and so on. From 80 to 89, from 90 to 99, and then from 100 to 109. Because it says less than 110, less than 110 is 109. So your boundary value on the upper end, your upper boundary is not included. And that is to exclude one value, so we don't have repeating values in an interval. Now, let's count. So the frequency is to count all of these particular values. Now, when we count all of these values, and you can count all of these values and make sure that you have the following values, which is 5, 7, 7, 4, and 2. So 5 values are going to be from 60 to 69, 7 values will be from 70 to 79, 7 values will be from 80 to 89, and 4 values will be from 90 to 99, 2 values will be from 100 to 109. Okay, so make sure that you take the time to pause the video and count all of those values. Now, your cumulative frequency is, as the name suggests, to accumulate or to sum up. So therefore, the cumulative frequency, the first one would be 5, so that remains the same. And now you start to add 5 plus 7, 12, 12 plus 7 is 19, 19 plus 4 is equal to 23, and 23 plus 2 is 25. So therefore, the sum of all the frequencies is equal to 25, and there we go. There's 25 rugby players. Draw an Ojive or cumulative frequency curve of the above information on the grid provided on diagram sheet 2. Now, the points that we are going to plot are as follows. So let's make another column here and we'll call it points. So the first point that you are going to plot here is going to be the upper boundaries of each interval with the cumulative frequencies. So therefore, the first point that you're going to plot is 70 and 5. The second point will be 80 and 12. The third point will be 90 and 19. And then it will be 123. 100 is the x value, 23 will be the y value, and 110 and 25. So once again, you will plot the upper boundary of each interval with your cumulative frequency. Those are the points that you are going to plot. Now there's one also very important point that you need to take off, which is your grounding point. Your grounding point will be the lower boundary of your first interval and 0. So that will be the first point that you actually plot, 60 and 0, and thereafter 70 and 5, 80 and 12, 90 and 19, 123, and 110 and 25. So let's go and plot these points and draw our cumulative frequency curve. Our cumulative frequency curve, remember, is an S-shaped curve. So the first point that we are going to plot is 60 and 0. 60 and 0 will be here. So there we go, 60 and 0. The next point will be 70 and 5. 70 and 5 will be somewhere there. Try to make your dots as big as possible. 80 and 12. So as you can see, guys, when you plot all of these, or join all of these points, you are going to get an S-shaped curve. And there you go. That's your cumulative frequency curve. So just make sure that all of your points are there. So once again, we got 70 and 5. Now that we have all of our points, let us answer our questions. The next question that we have is calculate the mean mass of the rugby players. The mean mass, the formula for mean is x bar, which is the mean. It's a sum over n, the number of values. It's mode. I'm going to press mode and stats, which is 3, and option number 1. And we got x values for univariate data. So let us put all of our values in. 78. Remember, after each value, you press equal to sign. 102. 88. Now the last value is 70 equal to. Remember, there are 25 values. At this stage, you press AC, Shift and 1. Now you want the mean, so we're going to press option 4, and the mean is x bar, which is 2. Press equal to 79.28. So 2.3. Our mean is equal to 79.28 kilograms. Now let's look at the next question. How many rugby players have masses within 1 standard deviation of the mean? From your calculations, calculate the percentage of the rugby players who have masses within 1 standard deviation of the mean. Now, for 2.4, in order for us to get 1 standard deviation of the mean, this is what we require. The mean minus 1 standard deviation to the mean plus 1 standard deviation. And this is our interval. So we're going to get our interval, and our interval will be as follows: 79.28 plus 1 standard deviation and also minus 1 standard deviation. So how do we work it out? Well, let's go back to calculator, Shift and 1 for stats. Let's press option 4. Now the standard deviation is option 3. So 3 equals 2. Let's round that to 2 decimal places. 11.02 kilograms. So my standard deviation is 11.02 kilograms. So let us now get our interval. So we're going to say 79.28. 79.28 minus 1 standard deviation for our lower boundary of our interval. 11.02 equals to 68.26. And the upper boundary of our interval will be the mean plus 1 standard deviation, 90.3 kilograms. So therefore, if they say lies within 1 standard deviation of the mean, we have to count all the values that lie between 68.26 and 90.3. So let's count. 78 is one of them, 88, 81, 90, 75, 76, 75. Now 68 is below 68.03, so we have to exclude that value. 90, 80, 77, 81, 69, 83, 91 is above 90.3, so we have to exclude that value. 80, 70, 81, and 70. So let's count how many values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 values. So 17 players. So therefore we have 17 players are within one standard deviation. So therefore let's work the percentage. So what is percentage going to equal to? 17 over the total number of players times 100. And that will change. So let's calculate the percentage. 17 over 25 times 100 equals to 68% of players. So therefore 68% of players are within one standard deviation of the mean. Learners, if you have not subscribed already to JL Maths, please do subscribe. Also, check out all the videos on jlmaths.com, and I'll catch you in the next video.